In this video, we will be looking at the happy number problem and build a solution in JavaScript while also computing the time complexity and space complexity of the solution that we will be building. Before jumping into the solution aspect, let us first try to understand the problem statement. We will be given an input number, let's say 19 here. It has two digits associated with it, which is 1 and 9. We have to find the next number, which will be the sum of square of the digits that are involved. So we have 1, so 1 square plus 9 square, and we have to keep doing this until we are able to find a 1. So in this case, next number was 82, then I went to 68, then I went to 100. From 100 I did 1 square plus 0 square plus 0 square. I was left with 1, and I was able to find this 1 as I kept on going in my sequence. That's why we said this is going to be a happy number. Now, what is going to be a unhappy number? A unhappy number is going to be a number that is never going to reach this outcome of 1 and will just get stuck in a endless infinite loop. For example, we started with 4. With 4 we went to the next number as 16, then we went to 37, we went to 58, we went to 89, we went to 145, we went to 42, and then next was 20, and then you found 4 again, and then it just continued by adding the sum of the squares of its digits, and it just keeps on going in the loop, and you never find a 1 as an outcome. That's going to be a unhappy number. Now that we have understood a bit more into the problem statement, let's see how we can achieve a solution. We said that we want to find the sum of the digits of a given number that we have. What we can do is perform operations like modulus and division and get each digit and then keep on adding the sum to come up with the next number. For example, what I mean is, we will say with 19, I will say 19 mod of 10. When I say 19 mod of 10, I am going to get the number 9. I go from right to left. After getting the number 9, I will just do square of it, plus I will say what is the next number that I'm looking for. The next number that I'm looking for is going to be 1 now. How do I get this one? To get 1 now, I will just say the new number is going to be 19 divided by 10, and it is going to give me 1. And then I will pick this one and do a square of that and then add that up to get my next number. And I will keep repeating this while my number that I have is always greater than 0. I will apply the modulus operation, find one of the digit, then remove that digit from the number and move on to the next one while this stays positive number. And then what I will do is I will keep doing this operation, like going from 19 to 82, then going to 68, and ultimately reaching my 1 until I don't find a 1, or I see that I am starting to see repeated numbers. So in this case, I started with 4, I went to 16, I went to 37, I came back to 58, I came back to 89, I came to 145, 142, 20, and then I started seeing 4 again. So in case I see the same number again, that means it's just going to go in an infinite loop and it's never going to be a happy number. And these are the two criteria which we will be using. And to keep track of this number, whether it is seen or not, we will be using a set, and we will just keep putting data in the set that we have as we iterate through a solution. And that's pretty much it in terms of implementation. Now let's jump into the code aspect of it. What we said is we will be keeping track of whether we have seen a number or not via a set. And to do that, I will just say let seen is equal to a new set. So this is going to keep track of whether the number that you currently have, that is formed from the sum of squares of the digits that you have with a specific number is there in this set or not. If it is there in the set, that means you're not going to be happy, it's just going to be an unhappy number. Find the digits and keep adding them up. And I want to keep doing this until I find my 1 or I see a repetition. So I will say that while my input, which is going to be n, is going to be not equal to 1. If it is 1, that means you have found a solution and it's a happy number and you just return true. And you have not seen a repetition. Now scene dot has n. If this becomes true, that means you have found a cycle which is going to be something like this. In that case, you don't want to keep on computing and checking again. As soon as you find that 4 gets repeated, you don't need to go again into the loop and see whether you find another loop, because then that loop will just continue. And so we say, while it is not in the set that you have not yet seen it, I want to keep on doing the operation of adding up the 2 digits of a specific number that I have. Within my while loop that I have, I will first make sure that I add it to my set as soon as I see the number. So I will say scene.add the number that I have in the loop. After this, I will try to update the value of my n, because then the next value is going to be dependent on the squares of the digits that are in the current number, and that will look something like get next value with my current n that I have. And this get next value function that I have here, what I will do is say constant get next value is going to be picking up a number, and then I will put some logic here to make sure I'm able to get the sum of the digits that are there and then update the new number. So the old value of n will then get replaced with the new total sum that we get, because here what we said, we started with 19 and we picked up 1 square plus 9 square. And to do that, first we said we will be doing a modulo operation and pick up the number that you want to have from right to left. So if you have 19, I will first pick up this 9, then I will say divide it by 10 and get the next number, which is going to be 1. And for that, you again find the square and add it up to this existing value. So to do that, I will keep a track via something called as a total sum variable. And in the end, this final total sum, after you have added up all the squares of the digits that you have in the current number, I will just return this total sum value that is existing with me. And to do that, I again need to go in a loop, and that will be while my number is greater than 0, I will first pick one digit. So the rightmost digit I'm going to just pick up. So I will say let digit is going to be number mod of 10. So this way, if I have 19, I do 19 mod 10, I will get my 9. With this 9, now I want to do addition into my total sum. So I will just say total sum is going to be with the existing total sum value plus the square of the current digit that you have. So you will just say digit star digit. And then what I want to do is update the number that I have with me. And the number that I have with me is currently num. The new number I'm looking for is doing 19 divided by 10, and then I will be getting 1. This one is going to be something like, you just say num is going to be num divided by 10, and that way you will get your 1, and then you will go in the loop again. Now when I say 19 divided by 10 1, this 1 is going to be 1 point something. So we want to make sure we are sticking to integers when we get this number. So I will just do mat.floor here and pick up this number, and this way my total sum will increase. After I pick up my 1, I will again try to do one check here saying whether this is going to be greater than 0 or not. 1 will still be greater than 0. I will go in the next iteration. I will do a mod here for the digit that I have, pick it up, do 1 square here, and then I will say met.floor num mod 10, and then this value is going to just give me a 0 for the next iteration, and then it's not going to satisfy this condition anymore because number has to be greater than 0, and we'll just exit, giving us this 82 value which we are looking for. And then after we get the next value and keep going into this iteration, if you are exiting the iteration, that is you have found a repeated value, in that case I will just return if n has to be equal to 1, that means you are a happy number. If n is not equal to 1, then it's not going to be a happy number. That's the final return statement that we just put here. Just keep on going in the loop and then exit it based on a repetition, or you have encountered a 1. That is the final output which you are looking for. And that's pretty much it in terms of the coding aspect. Now let's dive a bit into the time complexity that is associated here. The time complexity is going to be determined by this get next value function, because this is doing the digit processing aspect of it, wherein you are picking each digit from the number from right to left. We first picked up the 9, then we picked up the 1, and we keep doing this. Then what we do is once this ends, we just exit whatever value we are having, and after putting this equal to 1 check, the function implementation ends. And the core aspect, the major time that is going to be required, is going to be within this get next value function itself, and that is going to be determined by big O of log of n, because we will be determining the time complexity based on the number of digits that we have, and the number of digits that are going to be existing is going to be represented by log of n. And that's why the overall time complexity also becomes big O of log of n. Then coming to the space complexity aspect of it, we said that we are going to do this processing of getting next value and then keep on going in this loop that we have. The space that is going to be required is going to be heavily determined by this get next value function itself, because for each digit the space that is going to be determined is going to be based on the number of digits that we have, because this loop that runs is going to keep running as long as we have the digits within the number that you have received. So the more the number of digits, more space is going to be required for executing this total sum and keeping track of this digit and then updating the value that we have. That's why the space complexity, which is going to be tightly coupled in this case with the time complexity, is also going to be bigger of log of n. And that's pretty much it. Thank you for watching. Please like and subscribe.